Good morning. Okay. Today we'll start one new chapter. Chapter 8, Organic Chemistry, some basic principles and techniques. Okay. In organic chemistry, you already studied in your previous class, lower classes, organic chemistry, right? Okay. What are the points, the basic concepts you studied there? What are the basic points you studied there? Any one organic compound, can you say the name? Methane, ethane, butane, hexane, all alkanes only. There are alkenes, alkynes. Basically, three compounds you studied. They are alkanes, alkenes, and alkynes. In this chapter, we are discussing some basic principles and techniques related to organic chemistry. Some basic principles and techniques related to organic chemistry. First, you have to know what are organic compounds and what is the difference between organic compounds with some other compounds. Okay, here it is. Organic compound means the compounds prepared from plants and animals are called organic compounds. The compounds prepared from or obtained from plants and animals are called organic compounds, and the compounds prepared from minerals are called inorganic compounds. Compounds prepared from minerals are called inorganic compounds, and compounds prepared from plants and animals are called organic compounds. Can you say one example for inorganic compounds? Inorganic compounds. Any one example for inorganic compounds? Ammonium, ammonium ions, ammonium chloride, ammonium hydroxide, sodium chloride, sodium sulfate. They are examples of inorganic compounds. Okay, organic compounds examples that you already know: alkanes, alkenes, alkynes. Then another examples: aldehyde, ketones, carboxylic acids, alcohols, phenols are examples of organic compounds. Okay, so what is the difference between organic compounds and inorganic compounds? The compounds prepared from minerals are called inorganic compounds, and compounds obtained from plants and animals are called organic compounds. Okay, and one more point is that all organic compounds were found to contain carbon. All organic compounds should contain carbon. That is alkanes, carbon compounds. Alkenes also carbon compounds. Alkynes also carbon compounds. And other examples: carboxylic acid, carbon is present. Aldehyde also carbon is present, and ketone also carbon is present. Alcohol, okay, carbon which is making bond with the OH group, it is called alcohols. So all organic compounds containing carbon atoms. Is it is clear? So compounds obtained from minerals are called inorganic compounds, and compounds obtained from plants and animals are called organic compounds, and all organic compounds were found to contain carbon. So it is clear. And the first theory associated with the organic compound, it is vital force theory. What is the name of that theory? Vital force theory. The first theory associated with organic compounds, it is vital force theory. This theory, it is proposed by a Swedish chemist. The name, it is Berzelius. The name of the scientist who proposed vital force theory, it is Berzelius. According to him, vital force theory, it is a vital or mysterious force was responsible for the formation of organic compounds, and hence they cannot be prepared in the laboratory. Okay, according to vital force theory, an organic compound, how it is forming? An organic compound, it is formed because of the presence of a vital or mysterious force which is present in it. Okay, and according to him, the organic compounds we can't prepare in the laboratory. So it is clear. Okay, so the first theory associated with organic compound formation, it is vital force theory. Who proposed vital force theory? Proposed by Berzelius. According to vital force theory, a vital or mysterious force was responsible for the formation of organic compounds, and hence they cannot be prepared in the laboratory. But after and another, the vital force theory was rejected. Why? Because another scientist, that is F. Vogler, he synthesized an organic compound, urea, from an inorganic compound, ammonium cyanate. Okay, what is vital force theory? According to vital force theory, there is a mysterious force which is responsible for the formation of a organic compound. We can't prepare organic compound in a laboratory. But F. Vogler proved that we can synthesize organic compound. He synthesized an organic compound. The compound name, it is urea, from an inorganic compound. What is the name of that inorganic compound? That inorganic compound, it is ammonium cyanate. Okay, this is the preparation of organic compound urea from ammonium cyanate. The formula of ammonium cyanate, it is NH4CNO. NH4CNO. There, how many nitrogen atoms are there? NH4CNO, 2 nitrogen atom. How many hydrogen atoms are there? 4 hydrogen atom, 1 carbon atom, and 1 oxygen atom. Okay, here heat applied, and also it undergo a rearrangement reaction. Rearranged to give the compound, it is urea. What is the formula of urea? H2NCONH2. Okay, only the atoms were rearranged. Here 2 nitrogen atom in ammonium cyanate. Here also 2 nitrogen atoms. How many hydrogen atoms in urea? 4 hydrogen atom, 1 carbon atom, and 1 oxygen atom. Okay, so F. Vogler synthesized an organic compound urea from an inorganic compound ammonium cyanate. Okay, it is clear that we can prepare organic compound in laboratory. According to vital force theory, we can't prepare organic compound in the laboratory. But after this discovery, it is clear that we can prepare organic compound in laboratory. Okay, an example to support this one, it is F. Vogler synthesized an organic compound urea from an inorganic compound, that is ammonium cyanate. Other examples are also there. The synthesis of acetic acid. What is the formula of acetic acid? The formula of acetic acid, it is CH3COOH. CH3COOH acetic acid. It is prepared by cold. And methane, and another organic compound, that is CH4. It is prepared by Berthelot. Showed conclusively that organic compounds could be synthesized from inorganic sources in laboratory. Okay, 3 preparation techniques which supports the preparation of organic compounds in laboratory are: first one, it is preparation of urea, preparation of acetic acid, and preparation of methane. Yes, it is clear. Okay, so we can discuss the shape of carbon compounds. First one point we discussed, it is all organic compounds containing carbon atom. Okay, in the last chapter, that is chemical bonding and molecular structure, there we studied hybridization of carbon atoms. There are mainly 3 hybridization we discussed based on the number of bonds surrounding that particular carbon atom. What are the 3 hybridization we discussed? sp hybridization, sp2 hybridization, and sp3 hybridization. If carbon is making single bond, the hybridization it is sp3 hybridization. Carbon making double bond, the hybridization it is sp2, and carbon making triple bond, the hybridization it is sp hybridization. Okay, here we are discussing three organic compounds, that is alkanes, alkenes and alkynes. Okay, in your 10th standard, you already studied that the organic compounds were divided into two, that is saturated organic compounds and unsaturated organic compounds. If carbon is making single bond with other carbon atom, the compound is called saturated organic compound. Carbon is making triple bond or double bond, it is called unsaturated organic compounds. Okay, the saturated organic compounds are called alkanes. CC single bonded compounds are called alkanes. Unsaturated organic compounds, that is CC double bond and CC triple bond, they are called alkenes and alkynes respectively. So it is clear. The first one, it is alkanes. Okay, so organic compounds which contain only carbon-carbon single bonds are called saturated organic compounds. Example, it is alkenes. Alkanes example you already know: methane, ethane, propane, butane are examples of alkanes. If carbon containing 7 carbon atom, what is the name? Heptane. 10 carbon atom, it is called decane. 9 carbon atom, it is called nonane. Okay, and organic compounds containing carbon-carbon double bond or carbon-carbon triple bond are called unsaturated organic compounds. Carbon-carbon double bond, it is called alkenes, and carbon-carbon triple bond, it is called alkynes. Alkenes examples are ethene, propene, butene. Okay, etc. And alkynes are ethane, propane and butynes. Okay, next we can discuss the shape of different carbon compounds. Okay, alkanes, alkenes and alkynes based on their hybridization. First one, it is alkanes. Alkane means carbon-carbon single bond. Okay, carbon surrounding only single bond means the hybridization it is sp3. Okay, according to VB theory, sp3 hybridization, the geometry it is tetrahedral geometry. Tetrahedral geometry, the bond angle it is 109.5 degree. sp3 hybridization means all the bonds are sigma bonds. Okay, that also you studied in orbital overlapping concept. There are two types of bonds. There are sigma bonds and pi bonds. Axial overlapping will give sigma bonds. Sidewise overlapping will give pi bonds. In sp3 hybridization, axial bonds, the bond it is sigma bonds. One example, it is methane. Methane formula it is CH4. Okay, carbon, the hybridization it is sp3. How sp3 hybrid orbitals are forming? One s orbital and 3p orbital hybridized together to form 4 sp3 hybrid orbitals. So carbon, 1 s orbital and 3p orbital hybridized together to form 4 sp3 hybrid orbitals. Each sp3 hybrid orbitals will make bond with 1 s orbital of a hydrogen atom and forming which bond? Sigma bond. Clear? Carbon, 4 sp3 hybrid orbitals are there. Each sp3 hybrid orbitals will make sigma bond with 1s orbital of a hydrogen atom. So in this CH4 molecule, how many sigma bonds are there? 4 sigma bonds are there. Okay, sigma bonds are formed by the overlap of sp3 hybrid orbital of carbon with the 1s orbital of a hydrogen atom. Okay, sp3 hybridization, the geometry it is a tetrahedral, bond angle it is 109.5 degree. So in CH4 molecule, how many sigma bonds are there? 4 sigma bonds. Okay, 4 CH sigma bonds are there and the bond angle it is 109.5 degree tetrahedral geometry. Is it is clear? Like this, any alkane compound, the carbon hybridization it is sp3. If a carbon, you know that carbon valency it is 4. Okay. Each valency it is a single bond means the hybridization it is a sp3. Tetrahedral geometry and the bond angle it is 109.5 degree. So it is clear. Okay. Then next it is alkenes. Alkene means carbon double bonded to carbon atom. It is called alkenes. Okay, alkenes, the hybridization it is sp2. sp2 hybridization, the geometry it is trigonal planar and the bond angle it is 120 degree. Okay, sp2 hybridization, trigonal planar geometry, 120 degree bond angle, carbon is making double bond. One bond is sigma and another bond it is pi bond. How sp2 hybridization it is forming? One s orbital hybridized with 2 p orbital to form 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. In the case of ethene molecule, carbon, 3 sp2 hybrid orbitals are there. Out of 3 sp2 hybrid orbital, 2 sp2 hybrid orbital will make bond with sigma bond with hydrogen atom and 1 sp2 makes sigma bond with sp2 hybrid orbital of the second carbon atom. This it is clear. Okay. In ethene molecule, 2 carbon atoms are there. Each carbon atom it is sp2 hybridized. Okay. If you are taking one carbon atom, surrounding 3 sp2 hybrid orbitals are there. 2 sp2 hybrid orbital will make bond with sigma bond with 1s orbital of a hydrogen atom and the third sp2 hybrid orbital will make sigma bond with sp2 hybrid orbital of the second carbon atom. Okay, similarly the second carbon also. And you know that there is one unhybridized p orbital. That unhybridized p orbital will make which bond? Pi bond. Hybridized orbital will form sigma bond and the unhybridized p orbital will make pi bond. Okay, so carbon sp2 hybridization, 1 sigma bond and 1 pi bond. Okay, suppose carbon, you know that valency it is 4. Carbon valency 4. Here single bond, here single bond, here double bond. Okay, so which hybridization will choose? Single bond means it is sp3. Double bond it is sp2. Here both the single bond and a double bond is there. So preference will go to double bond. Okay. So double bond, the carbon hybridization it is sp2. And what are the types of bond? Sigma, sigma, sigma and here it is pi bond. Yes, it is clear. Okay. More than one kind of bond means preference order is there. Single bond, double bond is coming means preference for a double bond. Single bond, triple bond means preference for a triple bond. Double bond, triple bond will not come. Why? Because carbon valency it is 4 only. Is it is clear? Okay. Then next one more unsaturated compound is there, that is alkynes. Alkynes, triple bond hybridization, it is sp hybridization. How sp hybrid orbitals are forming? One s orbital hybridized with one p orbital to form two sp hybrid orbitals. Two sp hybrid orbitals, they are arranged linearly, linear, and the bond angle it is 180 degree. 180 degree. And here it is triple bond, means first bond it is sigma and two unhybridized p orbitals are there. So it will form two pi bonds. Is it is clear? So sp hybridization, triple bond, one sigma bond and two pi bond. One sigma bond and two pi bond. sp hybridization, what is the geometry? Linear geometry. And the bond angle it is 180 degree. Is it is clear? Okay. So there are two types of organic compounds, saturated organic compounds and unsaturated organic compound. Saturated organic compounds, carbon-carbon single bond. Unsaturated, carbon-carbon double bond and carbon-carbon triple bond. Carbon-carbon single bond hybridization, it is sp3, tetrahedral geometry and all bonds are sigma. Double bond hybridization, it is sp2 hybridization, trigonal planar, 120 degree bond angle, one sigma bond and one pi bond. Triple bond sp hybridization, linear geometry, 180 degree bond angle, one sigma bond and two pi bonds. Okay. And related to this, two questions are there. First question it is, how many sigma bonds and pi bonds are present in each of the following molecule? Total number of sigma bonds and pi bonds. Okay. For this compound they given, first we can draw the complete structural formula. Then it is easy to identify the sigma bonds and pi bonds. Okay. Before that, all should remember that carbon valency always it is 4. Clear? Okay. So CH3, first carbon, surrounding how many hydrogen atoms are there? 3 hydrogen atoms. Is it is clear? This is a CH3. 3 valency already satisfied. So it will make only single bond with the second carbon atom. Here how many hydrogen atoms are there? 1 hydrogen. Next, which bond is there? Double bond. Next, CH. Which bond? Single bond. Again, carbon, hydrogen. Which bond is present? Double bond. Next, carbon. This carbon. How many hydrogen atoms are there? 2 hydrogen atoms. Is it is clear? Okay, yeah. Any doubt? Okay. Carbon valency it is 4. First carbon making bond with 3 hydrogen atom. 3 valency already satisfied. One more valency is there. So it is a single bond. Next, CH. Here one bond. Here double bond. Then only it become total 4. Here CH, single bond, CH, double bond, CH, H. Is it is clear? And one more thing is that hydrogen, it will make only single bond. Okay. Carbon can make a single bond, double bond, triple bond. Depends on the compound. But hydrogen always it will make a single bond only. Hydrogen will not make double bond or a triple bond. Okay. After drawing this structure, you can easily identify the sigma bonds and pi bond. Single bond always sigma. Double bond, there are sigma bond and pi bond. 1 sigma, 1 pi. Triple bond, 1 sigma and 2 pi bonds. Now we can assign whether it is a single bond or a pi bond. This bond it is a sigma or pi. CH bond it is a sigma, 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 double bond, one sigma, sigma. Okay, so how many sigma bond is here? Total 1, 2, 3, 5, 8, 9, 10, 11, 12. So how many sigma bonds? 12 sigma bonds. How many pi bonds? 2 pi bonds. Is it is clear? Okay. So in this compound, how many sigma, how many pi bond? Here, first carbon, one hydrogen atom is there. Right side triple bond, 4 valency satisfied. Carbon, carbon, triple bond, carbon, hydrogen. Okay. Then how many sigma bonds and how many pi bonds? Sigma. Triple bond means 1 sigma, 2 pi. Sigma, sigma, pi, pi, sigma. So total how many sigma bonds are there? 1, 2, 3, 4, 5. So how many sigma bonds? 5 sigma bonds. How many pi bonds? 4 pi bonds. Is it is clear? Okay. So first case 12 sigma bonds and 2 pi bonds. Second case 5 sigma bonds and 4 pi bonds. In order to assign or identify sigma bond and pi bond, first you have to draw the complete structural formula. Okay. The 2 points you should remember, it is carbon valency always 4. Carbon can make single, double and triple bond, but hydrogen will make only single bond. That bond it is a sigma bond. Is it is clear? Okay. Then the second question it is, what is the type of hybridization of each carbon in the following compounds? 3 hybridization. Single bond hybridization it is sp3, double bond it is sp2 and triple bond it is sp hybridization. Okay. Both side different hybridization preference order. Single bond, double bond preference for a double bond. Single bond, triple bond preference for a triple bond. Okay. So I will write CH3 making single bond. Okay. What is the hybridization of this carbon? sp3 hybridization. Here it is CH3, CH2, CHO. So I will draw the complete structural formula. CH3, CH2, CHO. Listen here. The last one it is CHO. I told you here left side anyway single bond. With the hydrogen it is a single bond. How many valency satisfied? 1, 2. Remaining how many valency? 2 valency. Only 1 atom. If oxygen it is singly occupied, that means no other surrounding atom with oxygen means oxygen will make a double bond. Associated with oxygen, any one other atom is present means oxygen will make a single bond only. Oxygen alone it is present means it is a double bond. Some other atom with oxygen means oxygen will make a double bond. So here what is the hybridization of a carbon? Here full surrounding it is a single bond only. So what is the hybridization? sp3. This carbon surrounding 4 single bond. sp3. Then what is the hybridization of this carbon? Here 2 single bond, 1 double bond. Preference for a double bond. So what is the hybridization? sp2. So it is clear. Similarly, CH3, CH2, CH2, C. Already one valency satisfied. So carbon will make which bond with nitrogen? Which bond? One valency satisfied. Remaining 3 valency. So with nitrogen it is a triple bond. Then hybridization. First carbon sp3, sp3, sp3. What is the hybridization of this carbon? sp hybridization. Next compound CH3, C, triple bond, C, H3. Okay, what are the hybridizations? First carbon sp3, second carbon sp, third carbon sp, this carbon sp3. So it is clear. Then last compound it is CH3, CH, double bond CH, single bond C, triple bond C, H. What are the hybridizations? First carbon, full it is surrounding full single bond, sp3. Here one double bond, sp2. This carbon, left side double bond, sp2. Here it is sp, this one also sp. So it is clear. Okay, so how to assign hybridization? Single bond it is sp3, double bond sp2, triple bond it is sp hybridization. More than one bond preference is there. One side single bond, one side it is a double bond, preference for double bond, so hybridization become sp2. One side single bond, one side it is a triple bond, then preference for a triple bond, hybridization become sp. Okay, and sigma bond, pi bond, sp hybridization, one sigma bond, 2 pi bond for carbon compounds, sp2, 1 sigma, 1 pi bond, and sp3 hybridization, all bonds are sigma bonds. So it is clear. Any doubt? Okay, thank you.